All right, hello everybody. This is Mr. Merrifield here. I think I finally got my video set up going. So, essentially we're going to do kind of like a review topic each week. I'm going to pick out some really important things from Math 7, post them every week with a little bit of review assignments for them. So, today or this week we'll be doing some proportional reasoning. So what we'll start with is just some basic definitions. So we'll start with some definitions and some examples to kind of build on what we learned. So we're going to start with a ratio. So ratio, you might see it as a fraction. So you might see it as something like 60 over 2. However, a lot of times if you see it out in the real world, you might see it as just a ratio with a colon like this. So it could be 60 parts to 2 parts or 60 parts to 2 parts like this. And then we kind of tack on that. We'll take our ratio, we'll turn it into a rate. So we have a ratio, just a relation of two quantities, but we don't have any units on it. So to make it a rate, we just got to add some units to it. So we can take our 60 to 2, and we'll start with that. We'll use kind of a quantity you might have seen a lot in the real world. We'll take imperial system, we'll do 60 miles per 2 hours. And now we've got a comparison of quantities. We also got units on it. So we know first unit is miles. That's 60 miles per every 2 hours. We could also generalize that a little bit, make it a unit rate. And all we'd have to do for a unit rate is make one of these quantities 1. So to do that, we're just going to set up a proportion. So I'm going to take 60 miles per 2 hours. And a lot of you could do this math in your head, but I want to give you a setup just in case it's math that we really need to set up. So we're going to set up our proportion, and we're going to make one of our quantities 1. And that's what's required for a unit rate there. Think unit, unitary signifies 1. So to do that, I know it's a proportional relationship, so take the 2 hours to get from 2 to 1 hour. I know I just got to divide it up into 2 parts. And then I'll just do the exact same thing to the top. And I've got 60 divided by 2. So of course we can do that math in our head. It's just 30 miles. And then we could put that into what you might see with text. We could just write that as 30 mph, which is the exact same thing as this mathematical proportion here, just written kind of more in an English language, 30 miles per hour. So we got our basic definition now. Let's take a look at a problem where we have to use a unit rate to solve a problem. So we're going to look at this problem. We got Omar knows his friend Chris lives 3/5 miles away. So we look at this and we look at all of these quantities. We got 3/4 inch, 2 inches, and we have to say, well, what the heck does that mean? So essentially what they're saying is if you have a map, of course this map isn't going to span to scale. So of course, Omar doesn't live in a tiny miniature house next to Chris that's only 3/4 inches apart. This is a scale map. So if you ever see those scales, they kind of look like, they're usually kind of shaded in like this, and then they've got like these little dividers, and they usually say something like 1 inch is equivalent to maybe 5 miles. And that's like an example of what you'd see on a map. So we've got a map that's to scale. And we got to start relating the quantities that are in real life to the quantities that are to scale on this map. So first thing I'm going to look at is what information do I have? So we know that Omar knows that his friend lives Chris 3/5 mile away. So I'm going to go ahead and label that on that map. We know that this 3/4 inch, or this distance across here, that is equivalent to 3/5 miles. So we know that. So I can set up this proportion here that says that 3/5 miles is equivalent or proportional to 3/4 of an inch. So now what I want to do is I want to start looking at, well, what do I want to leverage this proportion as to do? So I'm going to go ahead and look at this second part. So how far is the school from his house? So there's a little bit of debate. Are we talking about Chris's house? Or are we talking about Omar's house from the school? And if we look at his house, we can kind of look at the first sentence. Well, it's in the perspective of Omar. So what we're going to do is we're going to say, well, we know that this essentially is the distance from Omar's house. So we need to find from 2 inches. So we could, of course, do some fancy math and get to it directly, but we're going to use a unit rate because it's a little bit easier. And if we use a unit rate, we can actually do this all using in our head math, kind of never breaking out the calculator at all. Of course, it's good though. So I'm going to start with my proportion. I'll write it down here to give me some room. So I got 3/5 miles is proportional to 3/4 of an inch on our 2-scale map here. So what I'm going to do to start is, if I had a unit rate, I could scale it into just about anything. So I'm going to try to figure out next, well, how much is 1 inch? So to do that, well, I need to find the miles here. So I can look at this and I can say, well, what do I need to divide 3/4 by to get to 1 inch? And I could multiply by a reciprocal, but I could also say any number divided by itself is equal to 1. So for instance, if I have a divided by a, that's equal to 1. So what I'm going to do here is I'm going to say 3/4 divided by 3/4 is equal to 1. And we could check that in our calculator if we want, but that's just kind of a mathematical property we know to be true. So do the same on the top. I've got 3/5. We're going to take that, divide it by 3/4. And again, you could break out your calculator for this, but we could do this all by hand. So we got to do the operation 3/5, divide it by 3/4. And I've got that weird video with a buff dolphin to describe what I do. I just keep, I change, and I flip. So what I'm going to do is I need to divide fractions. So I'm going to keep the 3/5, change this division into a multiplication, and then I'll flip the second fraction. And we could go through and we could multiply the top and bottom together, but of course I can also cross cancel. So 3 divided by 3, I can just cancel across. 3 divided by 3 is just 1/1. And now we multiply. 1 times 4 is 4. 5 times 1 is 5. And ooh, that's our magic number. We'll pop it in there. We've got 4/5 of a mile is equivalent to 1 inch. And so now we go, well, why did I even do that? So my goal here is to find out how far the school is from Omar's house, this distance across here. So all I have to do now is basically get it into, or essentially scale this into a rate that tells me the mileage distance for 2 inches. So now it's an easy operation. 1 inch scales into 2 inches. Well, that's 2 times as big. So I know this 4/5 miles that would span halfway across. I just got to double that. So double that here to get the top portion. 4/5 times 2. That will just become 8/5. And again, if you're wondering how I got that, I essentially did 4/5 times 2, which is the same thing as 4/5 times 2/1. Multiply the tops together, I get 8. Multiply the bottoms together, I get 8/5. And we could also specify this as 1.6. And then, of course, we want to put the units on. We'll just pop it on there. 1.6 miles for this distance here. Did I need to use a unit rate? No. Was it a little bit more elegant? Yes. So let's move on. Next example I got is kind of taking this rate stuff, tacking it onto proportional equation. So let's take a look at a problem. I used this problem earlier, but I cleaned it up. I changed it a little bit for this example. So we're essentially going to look at a problem where I go to a burger shop and I want to write an equation that tells me how much I'm going to spend for how many burgers I'm going to buy. So we're going to kind of tack this on piece by piece so we can see the logic of it as well. So just to read out the problem, I'm going to a store to buy burgers. I'm going to spend $10 to buy 2 burgers. So we're going to make an assumption here. So the assumption is that every burger costs the same amount. This isn't always going to be true. Sometimes you deal with non-proportional relationships, but it's a pretty good bet. So what I'm going to start with is I'm just going to make a table. So we'll start with, we've got a rate here. It's $10 for 2 burgers, and I could of course make a unit rate for it. A lot of you would just be able to see this relation right off the bat, but we'll just do it formally, just cause. So divide by 2, and I'm of course doing that to get the rate or the dollar cost for 1 burger. So to do that, 10 divided by 2, quick easy mental math, that's $5. All right, so now just to kind of see what's going on, we're going to make a table. So what I've done is I've made the number of burgers the quantity X, and I've made the cost Y. So what's going to happen with this is we can just easily fill in the table and we'll see what's going on. So the cost of 1 burger, that's 5. The cost of 2 burgers, oh, we already had that at the beginning of the problem, that's 10. And of course, we're just following, oops, that shouldn't be a division, that should be a plus. For every 1 burger we add, the burgers are $5. So we're going to add $5, so 15 for that. So what you could also do is you could use a multiplication operation for this. So you can ask yourself, well, if I have 1 burger, what do I multiply it to get the cost? Well, 1 times 5. If I have 2 burgers, I of course got to multiply by that. It's 5 as well. 3 burgers, I've got to multiply it by 5. We got this second sort of hidden operation. And then we can ask ourselves, well, how much does it cost for X unknown number of burgers? Well, I'd say no matter how many burgers I have, if it's 1 burger, I got to multiply by 5. If it's 2 burgers, I got to multiply by 5. 3 burgers, multiply by 5. X burgers, better multiply that by 5 as well. So X burgers better cost 5X, or 5 times X if you want to be really specific. So I can essentially write an equation. I can say, well, for cost Y, for an unknown number of burgers, Y is just equal to 5X. So I can write Y equals 5X. So one other thing I want to illustrate on this problem is this relates, we don't know it yet, but this relates to our K value, which was our constant of proportionality, which is what we defined it as. And it might not seem obvious, but it's also kind of the hidden unit rate. So what I'm going to do here is I'm going to compute a K value. So remember the K value, we always said that's going to be Y over X. So for each of these columns, I could just take the quantity Y, divide it by the quantity X, which is the same thing as saying, put it into a fraction. Fraction is just division. So say the K value, 5 over 1, well, that's 5. Well, K value here, 10 over 2. If we reduce this down, well, that also reduces down to 5. 15 over 3, that reduces down to 5. So what we found here is no matter how you find it, if you do a column like I did on the right and just start taking ratios of Y to X in a proportional relationship, you're going to find that K value. And so if I know the K value, I could just plug it in here and I could grab any K value. So for instance, if I gave you what I said, I'd go to a fancy restaurant where we're not dealing with this fancy restaurant. Let's give it like fancy hat. Now it's fancy. So say I go to a fancy restaurant and I say the equation is Y equals 15X. You could immediately look at this and say, well, Mr. Merrifield, the burgers must cost then $15 because that's the hidden unit rate there. So no matter if you get an equation or you're working backwards, or if you get kind of just like a description, you can work it back to an equation. And if you're given the equation, you can pop out the K or unit rate from it. which is why we always said that in our proportional equations, it's always going to take the form y equals k times x, or y equals kx. All right, one more example we're going to look at. We are going to look at what happens when we try to graph something like this. So we're actually going to use our example from before. So we've got our number of burgers, we got the cost, and we could just fill that in. We know one burger was $5, two burgers was $10, three burgers, $15. And we're going to go ahead and plot this. So I'm going to go ahead and label this. We know the vertical axis, that's our y. So we'll say y, that is, oops, let's fix that. We know y is going to be the cost, and let's just put some units on it. It's going to be US dollars. And then x, that's going to be number of burgers. We'll put some scalings on here. So because we know we're dealing in quantities of 5, let's strategically place our y-axis. We'll say that's $5, 10, 15, just going in quantities or jumps of 5, 20, 25, 30. We don't need to go up that high, we'll just label it anyways. 1 burger, 2 burger, 3 burgers, 4 burgers, 5 burgers, 6 burgers, 7 burgers, and we'll stop there. So what I'm going to do is I'm just going to plot the first 3 points from this. So we know that 1 burger right here cost me $5. So let's just turn that into an XY point. So we know this point is going to be 1, 5. X is 1, Y is 5. We'll plot it. We go over 1 at 5. Oh, and then we plot the second one. We got 2, 10. That'll be up here. We got 3, 15. That'll be here. And we'll just label those for good measure. So we got 1, 5. 2, 10, and 3, 15. So what I'm going to look at now, and actually first I'm going to pause 1 second because I'm just going to grab my line tool and I'm going to draw a line through these. So we actually also know one other thing is that we know if I don't buy any burgers at all, it's going to cost me $0. So we know a couple things from this point because it went up linearly like this. We know that this 0 point means you get no burgers because burgers is X. You know you spend $0. But we can also glean something else. So we can glean basically a k value in an equation. So if I look at this, I can essentially pop out any of these and take the ratio of it. So we defined k, our constant of proportionality, to equal to the ratio y over x. So right here, if we look at this point, k is going to be equal to y, which is 15, over x, which is 3, 15 over 3. What does that reduce down to? 15 divided by 3, which I can read this as, it's just 5. K value here, 10 divided by 2, k value here, 5 divided by 1. So if I were to ever give you a graph like this, you could just immediately pull the k value out. So k here, 10 over 2 is 5, 5 over 1 is 5, 15 over 3 is 5. We know this is a proportional relationship because it goes to the origin and it's a straight line, so I know it's a y equals kx form. K is 5, my equation, y equals 5x. And to show you a little bit how this works, I could say, let's plot like a super cheap burger joint. Let's go. And no, actually, I want something to line up on this graph. Let's choose something kind of expensive. So let's say we go to another burger joint and I say, oh, let's get a different color real quick. Let's do blue. So let's say I plot something like this. And I say this blue line is my fancy burgers, even fancier than the example before. So if I do this, all I have to do is pull out 1 point. So I could take this point right here. Notice that point is going to be 1, 30. The x value is 1. If I look along here, my y value is 30. And what I can do is I can glean a couple things. The equation that tells me why the cost for x number of burgers is y equals 30x. Why? Because that is the k value if I take the ratio of y over x. What I can also do is I can take this and I can figure out how much it'll cost for any burger. So essentially, I've got a k value, I've got how much it costs, and I can create an equation from it very easily. So the easiest point to pick out is always the one that lines up on the x value of 1, because notice I had this ratio 30 over 1, didn't even have to reduce it. I could, of course, if I were to kind of imagine this graph going up, I know it's also going to pass through the point 60, excuse me, that should be 2, 60, but that would still reduce down to 30 over 1. So to kind of review, you got your definitions. What's the ratio? What's the rate? What's the unit rate? You've got kind of an example of how to use a unit rate in a story problem to solve it. We've got how to essentially make a proportional equation and also graph it. And then with our blue line, we also know how to work backwards. So I'll post some review assignments. I'll also kind of align your Prodigy accounts to work on some stuff with this because it is an extremely important concept. And I'll kind of be in touch on what I'm going to post next week. So I hope you're all doing okay. Miss you guys a lot and take care.